Alright, so I want to welcome you back to the class where I've been able to handle the first three theorems. Remember that I told you in our previous classes that the theorems are not following the same pattern. In some textbook, you may see it not the same way I have itemized it as theorem 1, theorem 2, and theorem 3. The most important thing is to know the theorems and be able to apply them when you see questions. For the theorems, you've seen the one that we said that a straight line drawn from the center of the circle to the midpoint of a chord, which is not a diameter, is at right angle. We've also seen the corollary of the statement when we say that what now? A straight line that is drawn from the center of the circle is perpendicular to the what? To the chord. We've also seen the theorem 3 where I mentioned that that equal chords are equidistant from the center of the circle. So all of these things, and we have been able to solve questions on them. At least I was able to give you a few questions as regarding to all of this. So today, what's our interest? Is to move from where we are from the three theorems and answer three more theorems in this case. So let's look at this now. We're going to be looking at the angles at the center of a circle, angles at the center of the circle. What do we mean by that? That will lead us to what we refer to as theorem 4. And in this theorem, we want to look at the angle which an arc, of a circle subtends at the center is twice the angle the same arc subtends at the circumference. We need to know where the arc is. We know that the arc is just a part of the circumference. Now, but the reasons of it, if I don't want to say this, I can just say that the angle at the center is twice the angle subtended at the circumference of the circle. That is what theorem 4 is saying. That the angle at the center is twice the angle subtended at the what? At the circumference of the circle. I may like to show you this quickly as the case may be. Let me quickly show you this. So, like I said, I'm going to be showing you this. So if I draw a circle out this way, and I place here as my center, definitely you know. So if I draw this out, and I draw this here, and I draw this way, and I draw this way, and I decide to create a straight line from this point here. Decide to create a straight line from this point to this point, passing through this point. Do not forget that. So I'm going to label this space. Let's label this space point O. I'm going to label this space as my A, my B, my B, okay, my C. So now let's label this space, this point here. Let's call this one theta 1. Let's call this one theta 2. Let's call this place beta 1. Let's call this one beta 2. So we have theta 1, beta 1, theta 2, beta 2, as the case may be. So the question is, what is the angle here? What is the angle at this point here? That's why we said that we are trying as much as possible to prove that the angle subtended at the center of the circle is twice the angle at the what? The angle at the center is twice the angle subtended at the circumference of the circle. That is what we are trying to show. Now, you know that this from here to here is radius. From here to here is radius. So therefore, we can say that this triangle is forming an isosceles triangle. This is an isosceles triangle, meaning that our theta 1 is equals to theta 2. And the reason is the base angle of an isosceles triangle. That's number 1. We can as well say that because here is radius, here is also radius. We can as well say that our beta 1 is equals to beta 2. And the reason is not far-fetched, which is also what now? Base angle of isosceles triangle. Now, you have been taught the exterior angle theorem, that we said that the exterior angle theorem states that what? And the exterior angle, this exterior angle is equals to the sum of the two interior angles. This is what we are saying. So if you have labeled this place as x, let's label this one as y. So we are saying that our x is equals to the sum of these two, meaning that theta 1 plus theta 2. That is for x. And remember we said that theta 1 is equals to theta 2 because it is the base angle. So we can as well say that our x is equals to 2 theta 1, or we can say 2 theta 2. In that regard, if we have x to be equals to 2 theta 1, what happens here? So we are saying that the exterior angle theorem here, and why are we saying x is equals to theta 1 plus theta 2? The reason is because we are saying this is the exterior angle theorem. This is the exterior angle theorem. You know the theorem already. So we can as well say that our y is equals to beta 1 plus beta 2. The same reason, the exterior angle theorem of a what? Of a triangle. That is the exterior angle theorem of a triangle. So now, if y, we can just say that our y here is equals to what? Our y here is equals to, because we said beta 1 is equals to beta 2, so we can have here as what now? 2 beta 2. So if we have 2 beta 2, so that means the angle here, which is the sum, that means we are saying that our x plus y is equals to 2 theta 1 plus 2 beta 1 and 2 beta 1. If we factor it out, we are going to have here as 2 into bracket theta 1 plus beta 1. If you look at what I have here, look at the angle here. Look at it now. You can see that it's showing that theta 1 plus beta 1, which is 2 times. So that means the angle at this place is twice the angle at the circumference of the circle, and that is how we show this. So this is a theorem that you need to know. So when they ask you, whenever you see, if you are given an arc like this, and you are asked if the angle here is 8, and they are asking you that what is the angle here, definitely the angle at the center here will be 2 times 8. So 2 times 8 here, that means here is 16, and here is what now? Here is 8. So the angle at the center is twice the angle subtended at the circumference of the circle. So I want to believe that that explanation is clear enough for any of you to be able to see this, and you should be able to work with this. I would like to pause the video at this point.